Okay, good morning class. I'm your chemistry teacher, Li Yanting. Due to MCO, we decided using e-learning to conduct our lesson. The online platform that we use are Zoom. Okay, now we continue to our lesson. Class, today we will be learning about Form 4 Chapter 4, Electrochemistry, that is, electrolysis. Basically, in this topic, we will learn about electrolytic cell, identify the anode, cathode in the electrolytic cell, the direction of the ions move, and also the location of oxidation and reduction occurs. So here is some objective of lesson that we will need to achieve for today. Okay, first, students are able to define electrolysis, identify the electrolytic cell, identify anode and cathode, identify the direction of the ions move, and also the location of the oxidation and reduction occurs. Okay, before we start our lesson, I would like to show a short video regarding to our lesson today. So please pay attention on this video because this video is the overview of this topic.
Electrolysis is electrical current flow through a liquid which causes chemical changes. Yes, you did hear that correctly. Current flowing through a liquid. Now, not all liquids can conduct. The liquid can be a molten ionic compound or an aqueous solution. In either case, it must be able to carry current. Let's take a common example, table salt. If you heat sodium chloride to over 801 degrees Celsius, it will melt. The liquid will contain free-flowing positive sodium ions and negative chloride ions. This simply means that sodium and chloride ions are free to move within the liquid sodium chloride. Positive ions are called cations. Negative ions are called anions. Now consider putting two electrical conductors into the liquid. Copper would be good as it has a higher melting point. Nothing happens to the ions at this point, but if we connect the two bits of copper to an electrical cell or power supply, then things start to get interesting. We do need to sidestep for a moment to look at electrical current in a metal. From our lesson Behaviour of Metallic Structures, we know that electrons in a metal aren't bound to particular atoms. They form a sea of electrons that can move easily if a potential difference or a voltage is applied across it. This could be from an electrical cell or a battery. The electrons will begin to drift towards the positive terminal of the battery, and this is what happens when current flows. Current is the movement of charge. In this case, electrons. Now, let's go back to our molten sodium chloride. We've added our copper wires, let's call them electrodes, and now we'll connect these to an electrical cell. The electrons will start to flow in the wires, and this will cause one electrode to become positively charged and the other negatively charged. This has an immediate knock-on effect in the molten sodium chloride, which you'll remember is a mixture of sodium cations and chloride anions. Anything positively charged in the liquid, in this case the sodium ions, is going to be attracted to the negative electrode. And anything negatively charged, in this case the chloride ions, is going to be attracted to the positive electrode. This is because opposite electrical charges attract. When the ions meet the electrodes, electron exchange happens, and this triggers a chemical reaction. Solids can form, gases can be given off, and new solutions can be left behind. It all depends on the liquid and what material the electrodes are made from. There is more detail about this process in our lesson Interpreting Electrode Equations. There are special names for the electrodes, which are usually metal plates with a larger surface area than a piece of wire. The positive electrode is called the anode, it attracts anions, and the negative electrode is called the cathode, it attracts cations. The liquid is effectively conducting electrical current. The only difference is that the charge carriers in the liquid In other words, the charged particles that are moving are ions. If a liquid has free moving ions and can conduct like this, it is called an electrolyte. Remember that electrolysis can also take place in ionic solutions as well as molten compounds. The more concentrated that solution, the greater the ion flow rate. Ion flow rate can also be increased by increasing the potential difference or voltage across the cell. We'll be studying several examples of electrolysis in more detail in other lessons. For the time being though, here is a summary of the key ideas about electrolysis. Electrolysis is the flow of electrical current in a conducting solution or molten liquid that causes chemical changes. The conducting liquid is called an electrolyte and has free moving ions. The conducting plates, bars or wires inserted into an electrolyte are called electrodes. Positive ions are called cations and are attracted to the cathode. Negative ions are called anions and are attracted to the anode. When current flows in an electrolyte, it is the ions that move and carry the electrical charge. When current flows in the electrodes and wires, it is the electrons that move and carry the electrical charge.
Okay class, based on the video just now, do you understand what is electrolysis? Actually, if you pay attention on that video, you will eventually know what is electrolysis. Okay, so this is basically how the electrolytic cell look like. So what is electrolysis? Electrolysis is a process that happens in the electrolytic cell. So it is a process where the electric current flow through a liquid which causes chemical change. Okay, so this electrolysis will occur in electrolytic cell. So what is electrolytic cell? Okay, an electrolytic cell mainly have three parts. That is 2 solid electrodes and 1 liquid electrolytic solution. Okay, now I want you all to take out a piece of paper and a pencil. Let us draw electrolytic cell together. Okay, first, I want you all to draw 2 bars of electrode. That is 2 rectangle shape of electrode. Okay, done. After that, I want you all to draw a big beaker that immerses both 2 electrodes. After that, I want you all to draw a line that indicates the electrolyte solution. Besides, draw a line that represents wire that connect to the battery. So the longer side of the battery is represent as a positive terminal and the shorter side is negative. Always remember, the longer side of the battery, the symbol of the battery is positive and the shorter one is negative. So draw another wire connected to another electrode. So this is simply how the electrolytic cells looks like. Okay? So this is the more colorful of the electrolytic cell. Okay. What are the 2 solid electrodes? Okay. Do you know that? What are the 2 solid electrodes? These 2 electrodes are used to carry the electric current and it typically can find as electric conductors. So what is the electrolyte? Electrolyte is the solution inside the beaker that in the electrolytic cell that contains free moving ions. And both the electrodes will attract to a source of electrical energy such as battery. Okay? So, do you guys know how to identify which one is anode and which one is cathode? Okay, always remember, electrode and ions are different. So electrode, these both 2 are electron. and the free moving ions that contain in the solution is called electrolyte. Okay, these two are basically different things. Don't be confused, don't confuse. Okay, so next, so how you all to differentiate which one is cathode or which one is anode? Okay, here is some techniques to help you to remember. Okay, so which one is positive and which one is negative? We need to remember that the electrode that connect to the positive sides of battery is called anode, and the electrode that connect to the negative charge of the battery is called cathode. So here is some techniques for you all to remember. Panic. Just remember panic. P-A-N-I-C. Okay, P stand for positive, A stand for anode, N negative, I is C cathode. So panic stand for positive, anode, negative is cathode. This term of panic will only applicable on electrode, cannot use inside the ion. Okay, so inside the electrolyte there are free moving ions called anions and cation. So how about anion and cation? How to remember? So as you know that anode is positive, right? So this one is anode. Anode is positive. So the ions that inside the free moving that inside the electrolyte, okay, that inside the electrolyte will consist of three free moving ions. So anion will go back home, will go back to anode, and cation will go back to cathode. The simple way for you all to remember. ODE, the term that contain ODE is electrode. Okay, it's electrode. You see, ODE, ODE. So all the free moving ions, can you see that? ION, ION. So simply way to remember. So anion will go back home, that's anode, while cation will go back home, that is cathode. Meanwhile, ions got charged, so anions that will attract to the positive anode. That means anion is negatively charged. Same goes to cation. This one we know that anode which connect to the positive terminal of the battery is the positively charged. So positive charge will attract the opposite charge, that is negative. So basically we know that anion is negatively charged. Same goes to cathode and cation. Cathode is negative and cation is positive. This is the way for you all to remember. Okay. Besides the ions that flow inside the solution, electrons also will flow out from the battery in order for the electrolysis to occur. So how the electron flow? Electron will flow from positive terminal to the negative terminals. So positive terminal is this one and negative terminal is this one. So positive to negative. So the direction of the electron flow will clockwise from positive to negative. Okay? We know that positive is anode and negative is cathode. So the electron will flow from anode to cathode. Okay, some additional explanation on this. The battery provides a source of electrical energy. They will push the electrons onto cathode and making it negatively charged. Electrons are also drawn out from the anode and making it positively charged. Once this happens, an oxidation reduction reaction is activated. So what is meant by oxidation and reduction? Okay. Oxidation is the reaction that will lose electron. Okay, that means it is the site where the electron is released. Okay, we see it's the site where electron released. Okay, this one, right? So the electron pass through from positive to negative. So electron is released from anode. So anode will undergo oxidation. At the same time, while reduction is the reaction that will gain electron. That means receive electron. So back to the slide just now. Which one is receive electron? Okay, so cathode will receive electron. That means cathode will undergo reduction. Okay? So at the end of this lesson, I would like you all to do some exercise. First, define the process of electrolysis. So if you pay attention on our lesson just now, you will definitely know the answer. So number 2, identify the part of anode and cathode. A, B. Simple, right? And just now I already explained. So this homework I would like to you all to do and pass up. Okay? Thank you. So that's all for our lesson.